In this video, I'll show you how to find the derivatives of trigonometric functions using the chain rule. This will be part 2 of this series. We'll start off with the first question. Here we are asked to find the derivative of this function, and you will have to use a combination of the quotient rule and the chain rule. The quotient rule looks like this. Y is equal to, and if we assign this as g, and we assign this part of the equation as f, it's g, the function, and the derivative of f minus the derivative of g, leaving f the way it is, and at the bottom you will square the g function. So let's use this pattern. The derivative of y is equal to sine squared plus 10x squared. And we're going to rewrite this at the top. Sine squared x plus 10x. We're going to find the derivative of 5x minus 2. The answer is 5. We're using the power rule. 2 becomes 0. Minus. Now we'll find the derivative of g, which is going to be a pain. We're going to do it on the side here before we integrate it into our function. I'll increase the space. The derivative of g will be down here. This is the same thing as saying sine x squared plus 10x. So far we haven't done any derivatives, so our next step will be the derivative of this, which is 2 sine x. We're using the power rule here. This reduces by 1. And of course, the power rule and the chain rule are closely related. So the next step would be to find the derivative of this part. And the derivative of sine x is equal to cosine x. Wonderful. In addition, 10x, the derivative of that is 10. So we will place this into here. 2 sine x cosine x plus 10, and we leave the function f the way it is, 5x minus 2. Let's move on to question number 2. In question number 2, we have the following function, and the best thing to do when you have radicals is to convert them into fractional exponents. Let me demonstrate. Y is equal to 3x minus sine 6x plus 2e to the power of 4x. And originally we had a radical that extended all the way to here, and a radical is the same thing as saying 1 over 2. And similarly, we had a radical extending this part. So let's change that to 1 over 2 as well. The next thing we'll do is find the derivative of this part. And we will use the chain rule. Bring that 1 over 2 to the bottom. 3x minus sine 6x 1 over 2. And since we brought this to the bottom, you're going to subtract that by 1, so it becomes negative half. And now what you're going to do is find the derivative of the inside part, which is equally difficult, and we'll do it on the side here. The derivative of 3x is 3, and the derivative of this, once again, we'll have to use the chain rule. You bring this 1 over 2 to the bottom. This goes to the bottom. You leave the inside the way it is, and you subtract 1 over 2 by 1. The next thing you'll do is find the derivative of that. So the derivative of sine 6x will be cosine 6x, and then you find the derivative of this 6x, which is equal to 6. Now we'll take this and place it right beside the function that we had originally. 3 minus half sine 6x negative 1 over 2 cosine 6x times 6. And also, don't forget this part. So let's find the derivative of 2 times e to the power of 4x. This is quite simple. What you do is differentiate 4x, and the differentiated version of 4x is 4, and you bring it to the bottom, and you leave this exponential function the way it is. So the derivative is 8 times e to the power of 4x, and you place that right next to the function. So there you have it. That is the derivative of the function found in question. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.